We are constantly looking for ways to continuously deliver value. And we can do that by adding flood performance load tests within our pipelines. So join us next time on the DevOps Lab, where we're going to see exactly how to do that. Welcome to the DevOps Lab. Today we have a very special guest with us, Tim Koopmans from Flood, and we're going to be talking about performance testing. Welcome to the show, Tim. Tell us a little bit about yourself and about Flood.
Hey, Abel, thanks for inviting me on the show. Yeah, it's great to be here. Look, Tricentis Flood is a distributed load testing platform. I'm one of the founders, actually. I've been working on it for like 7 years now. And basically what we do is we support testers or engineers who want to use open source performance testing tools. We help them run those tests on the cloud. So we have like distributed execution across all the different cloud providers. And basically we get them up and running so that they can scale out, really large load tests basically. So that helps them with real-time analytics, also historical sort of analytics, but really just trying to dive deep into where performance problems are in their systems. So that's what we do.
Oh, cool. Do you have something to show me? I would love to see how all of this works.
Yeah, absolutely. Okay, so flood, the pun being that we flood systems has lots of sort of water-based terms here, but basically a flood is what we call a load test. And a load test is really just like a point in time sort of representation of performance metrics that you're interested in, say things like response time, concurrency, transaction rates, pass-failed rates. And basically we organize ourselves like in terms of streams and floods. That's really just how we run the test. But we also have the distributed load test infrastructure that I was talking about. At the moment, I've already got a grid node, which is a load generator running in Texas. But we make that super simple to basically use your own credentials. So if, for example, you want to run something on Azure, then you can pick a region where you want to run it from, pick all your scheduling options, so on and so forth, and make it super simple to get up and running with distributed load test infrastructure.
Okay.
Yeah, and I guess the third part of that is just being able to look at those historical results over time, which is what I sort of want to focus on today in terms of building this performance picture into your DevOps pipelines. I guess the end state for today, like what I really want to insert is performance into the pipeline. I've built a dashboard in our system here. I've done one for something that I've been testing for a while here. The project's called Azure DevOps. Pops, because I think people like putting performance or putting words in between DevOps. So I'm just going to call it DevPops. Actually, I wouldn't mind talking about that, but this is kind of like the end state of where we want to be. So I've just got a snapshot of this project. It's the last 30 days, and it's telling me that things are going wrong in this particular project in terms of performance. Like there's been a 256% increase in response time. Our pass rate is dropping for some reason. And basically, yeah, this is going to really help us kind of find out like what's happening with the system under test and, like what happened in this particular commit. And like, let's have a look at that commit and, okay. who changed this, who caused this performance regression. So that's kind of like the end state.
Yeah.
I think it might have been you actually, Abel.
Of course it was.
Yeah. So we need to we want to do this continuously so, that we can end up at this sort of point. So that's what I want to sort of show you today, how to get to this point with pipelines.
Interesting. So it looks like it gathered historical data, historical performance data, and then it starts flagging when things start skewing from what has traditionally been the response times. Is that what's going on?
Yeah, absolutely. I mean, it's everyone has like a different picture of performance, like things that matter to them. So it's really important to be able to just ask and answer questions about your own performance picture. So like a lot of people will focus on performance characteristics, but sometimes people are kind of interested in other aspects of performance. I call it PEARS because just to make it mnemonic that you can remember, but like we'll look at performance today, but sometimes people are interested in elasticity or how well they can scale out and scale back in, availability, like uptime, making sure that systems are always up, reliability, making sure that the systems give back the right information, not caching some weird state. And, scalability is kind of like a nod to the traditional sort of capacity planning, making sure you got the right size infrastructure. So people have different things. But the whole point of Flood is to kind of let you test and then answer those questions that you have around that, those attributes.
Got it. So then let's say I have some type of app, right? Let's some type of web app. It's running in Azure App Services or maybe in AKS or something like that. What would kind of be the process? I would write my performance tests. How do I hook that into my pipelines, and how do I get that information, the performance test data, into Flood? How do I start gathering all this historical data?
Yeah, absolutely. So, well, the first thing you're going to need is a performance test. You need some way to simulate the load. And we support different open source tools, but the one I want to show you today is what we call Flood Element. And essentially that is a different take on the traditional network or protocol level load testing. This is what we call browser level load testing. Okay. And it really solves that complexity issue in terms of just being able to simulate realistic user behavior within a browser. So that's what we'll show you today. That's one of the ingredients, I guess, to building a pipeline. That's why I say it's all about the browser here in my show notes. But the other sort of essential ingredients are going to be, I've used the DevOps starter pack, for example. This is just, as a newcomer to say this part of the process, the starter packs are excellent. They can kind of get you up and running. And I've just used like a really basic static website for this particular example. Okay. We've got the whole DevOps Azure Pipelines. So that's where we'll kind of factor in how we run this load test continuously. Okay. And then we'll sort of get into like how that comes back into the results as well. So the key thing here for me is that like the difference between, say, traditional performance testing where you go and do a test and you might wait for the results and make a decision. The key here is to kind of not do that. Just do this continuously. So run a small load test with every build, for example. And what that helps build is that empirical baseline so that if performance does change, then you can go back and find out when it changed. And if you've been running it with every build, for example, then you just have like a much smaller sort of surface area to look at in terms of where the regression happens. So that's what I really want to encourage today, is just building that sort of continuous pipeline of performance. So
very, very cool. So let me just make sure I understand what's going on. Yeah. So you have your website, right? You have your CI/CD pipelines. You've set up Flood, and then you've got your load tests or your performance tests. And then as I'm checking in, right, my pipelines are going to fire off, and then within my pipelines now, you're running these load tests, these little load tests, little performance tests.
Exactly.
And as you run them, that data is being pushed over to Flood. You guys give me that nice historical charts, and if any anomalies occur, I can pretty much see it pretty quickly.
Yeah, absolutely. And the real magic is like not hanging around waiting for these tests. Like we run CI/CD all the time, right? Thousands of builds. The real magic is if you've got that empirical baseline of performance data, you can always go back and say, oh, what actually changed? And you have much less code to look at the end of the day. So just inserting it into your build pipeline, like you just described, is exactly what I'm encouraging. Like get a small test happening, and we'll call it a baseline today. So I can show you how to build that if you like.
I would love to see that.
Yeah, awesome. So the key ingredients, like we've already got this pipeline here, and we'll get into sort of editing this shortly. But we don't have a load test yet, so we can't really add a load test here until we have built a load test. So what I'll do is I'll quickly show you that. Actually, I'm doing everything in the browser today, which is kind of cool. Cool. So I've already installed Element, but what I'm going to do now is just install some specs or use Element to generate some specs. These are going to be performance based specs.
Gotcha.
And hopefully it doesn't take too long. Maybe I should have done that before. But we're just going to call it specs, which is fine. We're going to pass it the URL, which is a static URL that we've built with this, the DevOps starter pack. So we're going to put that in here as the target.
Okay.
I'm just going to call it baseline because that's kind of what we're doing is a performance baseline. And what element we'll go and do is just basically create the scaffolding for this performance test. And then we'll be able to edit it shortly. Once it's done, we should see it in our code. Now, this is another really nice thing about like performance testing. Another practice that I kind of want to encourage is you should be treating your performance tests as first-class citizens. You know, you really should have these tests checked in alongside your application code, ideally, like you do with unit tests and other functional automation tests. It's really good to be able to have it all sort of sitting in here.
Absolutely.
So I'm just letting that finish off there, but it looks like it's already started to build the script for me. And this is pretty much what a Flood element script looks like. It's written in TypeScript. So, you know, it plays really well with things like VS Code in terms of code completion. And if you've ever done any type of functional test automation before, you'll realize that this sort of async await pattern is kind of similar to, say, Selenium JS. We did borrow some of the style here. And you can do things like, you know, interact with a page, like go and visit it, take a screenshot. But then you can also do other things like you have selectors and locators. You can find elements on a page and interact with them, type things into search boxes. So it's full, you know, browser automation, but, you know, in a performance testing context.
Cool.
What I might do though is actually, I'll see if I've got, can we edit this out? I'm not sure. I've actually got some code examples here. Let me just open up my editor and see if I've still got it. Oh, there we are. So I'm just going to steal some stuff here so that we don't have to watch me awkwardly code things in here. But basically, instead of doing this sort of step here, which is like finding a heading which doesn't actually exist on the target page, what I'm actually interested in is kind of this link here. So basically, I want to be able to go to this page, find this link, which actually has a convenient ID attribute. So it's going to make it easier to follow, and then just like follow the link and do some validation. So that's all it does. You know, this amazing single page application that's sitting in an iframe there.
Right.
So we'll go back here. I'll add that in. Actually, I'll just copy that whole step from my notes. And what I'll do is the really nice thing is here, as you're kind of building it, you can actually just test it all locally. Like you don't need Flood at this point in time. So it's almost like a functional test automation tool at this point in time.
Yeah.
So what we can do is I won't do those two things because we'll talk about that in a second. But we can just run this test, element run specs baseline. And once again, this is all in the browser. So I love working with code spaces. It's pretty cool.
Yeah.
And we can just kind of validate that the test is doing what it needs to do, which is, you know, go to this website, take a screenshot, find an element by the ID app, and then click on it, and then take another screenshot. And that's all it does. And so at this point in time, let it finish. What we want to do is we might need to add these files actually. New specs. So that's cool. We have like, now we have the test in our, you know, alongside our application code. There's not much here, but, you know, we have a specs directory, we have specs, and now we just really need to know how to execute them, right? Execute them on Flood.
Yep.
So to really join the dots there, all we need to do is go over to our DevOps pipeline here. We're already in edit mode, so I'll just drop the size down a bit so we can see. And what I'm going to do is just add a batch task. Now, there's so many different ways you can skin this, of course.
Sure.
But one of the nice things about Flood is that we have an API which pretty much lets you do anything that you can do in the UI. You can also do programmatically through the API.
Cool.
So what I'm going to do is just copy this thing here.
Okay.
And actually, I'm just going to do an inline script for now because I haven't checked this in. So We'll just do it in here. I'll quickly talk through it.
Okay.
We're making an API call to Flood. We're saying what tool you want to use. We want to use Chrome in this particular case. We want to run 20 threads or 20 browsers. We'll give it a name. we're going to say where this test is coming from. So this is the path to the file that we just checked in with our code, and what project we want to run and how long we want to run it for. We're also using some sort of canned variables that come out of DevOps itself, or sorry, the pipeline itself. So we're interested in sort of tagging the Git ref. So we want to know what the full path to that to this commit is, and we're also going to run it in a particular region. So we want to tell, like Flood, which geographic region do you want to run this load test from? And that's kind of all we have to do. We can actually give it a better name than that. Just call it baseline. And now if I sort of save that, do a test run.
Okay.
And what's going to happen is it's going to go through the standard build and deploy that we've defined. It needs to wait for a cloud agent, but basically as soon as it picks up an agent, it's going to run through the build steps and then launch that test programmatically. So now, like the test that we've built over here is now intrinsically linked into our build pipeline, if you like, and it's just going to happen in the background every time you do a release.
Very cool. And like you said, it's just by passing in a variable, I can say, you know what, I want to, pardon the pun, I could flood my test now with 100 different instances or 500 threads or something like that. Is there a limit to what I can do?
There's always there's always a practical limit to how big you can go in the cloud, but we have customers that launch thousands of load generators across 15 different regions. So realistically, this box here is like a standard D4 V3 instance. It's I think 4 virtual cores and 16 gig of RAM. Yeah. There's really, provided the data center that you're running it in has enough capacity, you can go as wide as you like. You can do kind of insane load tests with this, but I guess my point though is that's kind of where everyone kind of focuses. The big, the star of the show is the big 1 million user load test. But I think the true hero is the little 20 user baseline that you're continuously running all the time, because that baseline is what's going to get you to this kind of point. Just finding, hey, what happened with this cliff here? Why did performance change? Right. And if you think of those big 1 million user load tests, you're only kind of running them once in a blue moon. You know what I mean? Sure. So you've got more things to look at. Whereas this is kind of like your little private eye detective just running in the baseline. It's you kind of forget about it, to be honest. We run thousands of these on our own build system at Flood. And it's really useful to just be able to go back in time and say, hey, what's actually changed, and get to the bottom of it. Great,
and it's just in your pipeline. I think you said this, but I must have missed it. When I set up my test and stuff, I get to choose which region I'm executing my test from, right? So I can choose different regions, maybe somewhere in the US, maybe some tests, I want 2 tests to run in Europe and some in South America or something like that.
Absolutely. Yeah, absolutely. From the API, it's just the regions tag, but it's probably just best to visualize that. I can sort of show you when you're starting, with a particular cloud provider like Microsoft in this particular case. It's just whatever region you want to pick here. And so if I want to start running stuff from Washington, I can do that. And if I want this particular load generator to have 10 nodes, I can do that as well. Oh, cool. And you can control all the scheduling. You can do all this programmatically. Of course, I'm just showing you through the UI because it's a bit easier to consume. And yeah, that's pretty much it. So what will happen now is we're just basically using ARM, the resource manager to go and provision these instances. These are just VM scale sets, actually. So yeah, just VM scale sets running a Linux image, and they're just starting up load generators. And so they take about 3 to 5 minutes, depending on the region. But once they're ready, you can start distributing load to that. And then the beauty about it is you don't need to leave this stuff running all the time. You can just throw it away when you're done as well. So I'm sort of showing you what it looks like when you're running on already provisioned infrastructure. But of course, you can do this on demand as well. So it's, you don't have to do these sort of manual steps. I'm just doing it for the purpose of the demo, I guess.
Right. So I can literally, from within my pipeline, spin up whatever agents that I need to generate whatever load I need. And once I'm done, spins it all down, finish out my pipeline, right?
Exactly. Yeah, exactly. And in actual fact, if you don't specify, like when you're creating a flood, there's lots of different examples here, but you can do stuff on a new grid, you can do it on multiple grids, you can do it on an existing grid. So there's many different ways to do it, and you can control like how long that grid's going to stay around for. Otherwise, we will just shut it down anyway once the flood's done. So we don't leave the infrastructure running if you don't need it.
Man, this stuff is so cool. Thank you so much for showing us. I always say DevOps is all about continuously delivering value. And if our performance sucks, we're kind of not delivering any value. And what works on my machine, it doesn't necessarily translate to what's going to work when I open up the floodgates and my end user starts pounding on it, right? So just by having the ability to run all of these tests within my pipelines, that's freaking awesome. I love this. I love having the ability to do all this. I love when you said, you know what, the real value comes when you run those small tests over and over again, so you get that baseline within your pipeline every time your pipelines kick off. That's so incredibly valuable. So viewers, if you want to learn more about this and learn more about Flood in Azure, check out those links below and join us next time on the DevOps Lab.